Today I'm going to be presenting to you guys a little bit of the steps of the photochemical texturing process that I have been developing over the past year with Gabriele and more recently with Vinicius as well. The primary aim of my work has been to evaluate the geometry of these circular pockets. We call them dimples. Yes. The geometry of the circular pockets or dimples within masks created using the photolithography technique. These masks will subsequently serve as a sort of mold for material removal, or we can also call it as micromachining, through chemical or electrochemical texturing. In my case, electrochemical texturing. Given the very delicate nature of the photolithography process, studying its parameters is crucial to ensure the successful outcome of both the masking and the final texturing process. So, as basically mostly all of the projects, we start off with the cleaning of the sample, preparing the sample, starting with the sanding process with sandpaper of 1200 grit per square inch. And then we go to the polishing machine to do the polishing process with 1 micrometer aluminum powder, and then drying with a hair dryer. We do this to make sure that the surface of the sample is completely clean and with a mirror-like finish, but mostly because we don't want any particles to interfere with the process of making the mask itself, so that's why we do this. And then we put the sample onto the spinner machine, which was a machine created especially for this by Felipe. Before we do that, we apply the resin, very important step. We use a pipette to suck a little bit of the resin and carefully deposit it onto the surface of the sample. And then we use the spinner machine to spread the layer and make it as thin as possible and spread out evenly, hopefully. And after testing several different timings in this step, we arrive at the conclusion that 8 seconds is sufficient time to create this thin layer that we are looking for. Then we go to the pre-baking process, which is done in this machine, the heating plate. This process is done at 90 degrees Celsius, approximately. We do work with a little bit of a temperature range from 89 degrees Celsius to maybe 100. It's not very specific to 90 degrees, but we try to stay close to this temperature. It is done for over 10 minutes. Of course, we wait for the heating plate to achieve approximately 100 degrees, and then we put the sample on top of it, and then we also wait for the sample to arrive at this temperature. This part of the process is supposed to improve the adhesion of the resin to the sample surface, which is vital to ensure that the photoresist mask remains intact during the subsequent steps, which will be, in my case, the chemical texturing process. Then we put the sample, after we have done the pre-baking process, we carefully put the photographic film on top of the sample, being careful to align them. Not really, that's not really important. We need to keep the matte side, that's the important part, keeping the matte side of the film facing up and completely in touch with the surface of the sample. Then after we do this, I use some tape to glue the photographic film on top of the sample. And sometimes I also use tiny glass plates, which have not really worked before, because as I'm going to show you guys this result, this is what happens when I broke the glass plate. There's a pretty huge part of the sample that did not really texture, did not really develop the mask, but that's just some details. We work with what we have. And then, once the sample is carefully placed in the center of the ultraviolet light chamber, which was also built by Felipe for this specific reason, we expose the sample to UV light radiation for precisely 1 minute and 10 seconds. It has to be this amount of time. Specifically, Vinicius has told me this. I did not know that it had to be 1 minute and 10 seconds before. I was working with 2 minutes, 3 minutes, and it did not work as well as it did this time. So 1 minute and 10 seconds precisely. And how does it work? the light passes through the patterns, since they are transparent, weakening the resin only in the desired circular shapes. The resin of the filament is dark. Since it is dark, it blocks the passage of the light on the rest of the sample, and it ensures that the mask remains intact in the remaining surface. Then we do the developing part, which is the step where we actually see the mask developed. So in order to remove those weakened parts that we have weakened with the exposure to UV light, we put the sample submerged into a solution of photographic developer called AZ developer and agitate the solution for over 5 minutes. This is not as specific and precise as the 1 minute and 10 seconds in the UV exposure, but it has been working with 5 minutes, so we keep using this amount of time. And after that, the sample is washed with soap and water and dried. So, as I shown before, I gave you a little bit of a spoiler, but this is the result of the photolithography process. This is only the mask. We do not have the actual dimples printed on the sample. We only have this sort of mold, as I said before. I'm going to draw it to make it easier for you guys to see this. So here we have the sample. Yes. And then we have the mask. And the holes only in the mask. So this is what we have achieved for now. And then we go to this next step, which would be the chemical texturing. We have been using the chemical texturing technique instead of the electrochemical because the aim in this part of the project is to see if the mask is actually being resistant enough. So that's why we are using the chemical texturing process, even though that is not the initial idea that we have to apply in a larger scale production. So to do this chemical texturing process, we use distilled water and nitric acid. And it works like this. We have an aqueous solution prepared, composed of 5% nitric acid and 95% distilled water. Being more specific to the measurements, since the nitric acid that we have available to us in the metallography laboratory is only 66% concentration, it has only 66% concentration of nitric acid. We do this measurement of 92.5 milliliters of distilled water and 7.5 milliliters of nitric acid. And then, when this solution is done, we submerge the masked sample and agitate it, completely submerged, for over 2 minutes. Yeah. This rate of material removal that we're looking for is proportional to the exposure, to the amount of time that we expose the sample to this solution. Since we currently are working with testing less deep dimples, we are leaving into this amount of time, which would be sufficient to create these actual dimples that are not very deep. And then, after this is done, we have the result of the actual texturing process. This, as you can see, normally these dimples would have a more darker shade, but I did the terrible act of wiping it with algodón, with cotton. So it has this white color because of that. But it has to be kind of like that. At the end, it will look probably like that. And as a last step, we do the ultrasonic bath to remove the mask, because after the texturing process is done, the mask has served its purpose, so we no longer need it. So we just And that leaves us with the texture sample, basically what I have been doing. Thank you.